Hey guys, this is Cristo. So today we're going to be overviewing 4.7 and 4.9 lecture material. So this was about 2 weeks ago lecture material, and I looked over Dr. Plummer's videos on the reactions of carboxylic acids and their derivatives. So the material that I prepared for the SI for this week was basically to overview those basic concepts. Well, let's get to it. So, if we could start right there, yeah. So, which of these groups? Oh, and something else to note. So, the title here. So, for example, let me highlight it. This right here. You're gonna see at the top of each page, and that corresponds to which video I got the material from. So if there's anything that's a little bit, unclear, you can always go back to that video that Dr. Plummer prepared and learn or practice. So, question number 1: which of these groups undergoes nucleophilic acyl substitution? So we know that the only groups that don't undergo this substitution are ketones and aldehydes. So we eliminate A, B, because they're ketones and aldehydes respectively, and then C because that is also an aldehyde. And so what we're left with is D, which is a carboxylic acid. So question number 2, draw the tetrahedral intermediate of the following reaction. So here we have a nucleophile that's reacting with a carboxylic acid. So the intermediate would look something like this. Here it's a little bit unclear. I'm just going to zoom in, try to draw a little bit better. There we go. Oops, that's not supposed to be there. Okay. And now, your nucleophile, and you have your OH, right? So this is the intermediate, and what's going to end up happening, I'm not going to draw it, but OH is going to leave. Ooh, that's very light. Oh my gosh, it's such a mess. OH is going to leave, right, and the nucleophile is going to stay. Okay. Question number 3. Is the reactivity ranking below correct? So you have most reactive acid chloride, followed by anhydride, followed by carboxylic acid, ester, and then finally an amide. So this is correct. And amides are the least reactive, and then acid chlorides are the most reactive. So question number 4. Which of these reactions is correct? So we know that a more reactive carboxylic acid derivative can be turned to a least reactive carboxylic acid derivative relatively easy, though the opposite is not necessarily true. So, based on that, we know that acid chloride can form carboxylic acid. We know that carboxylic acid can form an amide. We know that anhydride cannot form a we know that an anhydride cannot form an acid chloride, and we know that an amide cannot form an acid chloride. So, number 5, circle the worst leaving group. So the worst leaving group is going to be the most stable, and also the least reactive. So that's going to be this amine right here. Alright. So, reactions of acyl halides. So this is from the reactions of acyl halides video. It's just going to do that. So, what is going to happen if you have water and an acid chloride? Well, you're going to form a carboxylic acid. What about if you have this group and an acid chloride, you're going to form an anhydride. And what if you have making an amide from an acid chloride? What happened there? So we know that we need 2 equivalents of this amide group. So that's right here. That's way too big. I gotta magnify. So here we go. So we know we need 2 equivalents of CH3 in H2, right, to form that product. And finally, how are we going to form an ester from an acid chloride? Well, we can just do a primary alcohol, right? Man, I don't know what's going on with this drawing. A primary alcohol. Okay. So now reactions of acid chlorides. So these are special case reactions. So the first reaction, we have LiAlH4, ether and acid. So what that's going to do is that it's going to form a primary alcohol. So phenyl group, it's going to form a primary alcohol. And then the second reaction, we have a Grignard reagent. And what that's going to do is that it's going to insert that CH3 group twice because it's 2 equivalents. And so we're going to end up with a tertiary alcohol. Okay. And then number 12, we have that, and we're going to end up with a ketone. Okay. So now that we're done with this, we're gonna go back up. Oopsie daisy. Go back up. And we're gonna do the rest of the problems that I have prepared. So this material is from Reactions of Anhydrides video that Dr. Plummer prepared. So the first question is, what reactions are plausible for anhydrides? So an anhydride can form something that's lower in energy and less reactive than it is. So an anhydride can definitely form a carboxylic acid, an ester, and an amide. So for 2 to 4, we're going to finish these reactions. So what happens when you have 2 equivalents of water reacting with that anhydride? So we're going to form 2 carboxylic acids times 2 carboxylic acids. What about if we have that amide group reacting with the anhydride? So we know that we're going to have this product, NH2, right? But we also know that we're going to form a carboxylic acid. I'm not going to draw it, but just keep in mind. So what about if we have a primary alcohol reacting? We are going to form an ester. Great. So now, is the following reaction possible? Here we have an anhydride being reacted with an ion of chlorine and forming an acid chloride. So that is not possible. So let's keep on going. So reactions of esters. So for 6 to 8, we're going to finish the reactions, and for 9 through 11, we're going to go over special case reactions of esters. So for 6 through 8, what happens if we have H plus, an acid, and water with an ester? So we're going to form a carboxylic acid. You know what, actually, let me make this a little bit thicker. I think that'll be better. Number 7, what if we have that amide group with the ester? We're going to form this. Oh yeah, should have done that earlier. And what if we have that primary alcohol and an acid? So this is going to be a trans esterification for number 8, and we're just basically going to replace one ester with the other. Right. So special case reactions of esters. So for number 9, we have LiAlH4 ether, and I forgot to put in here, but let me do it right now. So that little star right there means that there also needs to be H3O plus. So sorry about that. So what's going to happen is that this is going to form a primary alcohol. So you can draw that. And then if we have ester with diol, then we're going to form an aldehyde. So less reduced, we have Grignard reagent. Then we can add the Grignard reagent up to 2 times on the ester. So let's say we have one equivalent of the Grignard reagent, then our product is going to look something like this. FRH here, and then we have our phenol group right there. Great. So now we can keep on going. And now we're up to reactions of carboxylic acids. So we have to finish the reaction for number 1. So we have a carboxylic acid forming an ester. And so what we can use is a primary alcohol in acid. So let's put the acid first and then the primary alcohol. CH3OH. And then we have carboxylic acid with an amine heated up. So we're going to form this amine group. Awesome. And then what about if we have a carboxylic acid with a primary or a secondary amine? We will use DCC as a reagent instead of heat for this reaction to progress. And so what will end up is this product. Okay, so we also have the following reactions, which is directly a substitution reaction. So we can use PbR3 with a carboxylic acid to form that product, or we can use SOCO2 or PCO3 to form this product. So these are strictly substitution reactions. So we have 2 equivalents of carboxylic acid, and then we have phosphorus pentaoxide, or we have extreme heat, 100 degrees Celsius. So here we can form an anhydride, and just because I'm going to run out of space, I'm not going to draw it, but form an anhydride. Number 7, so here we have 2 carboxylic acids in a chain, and if we heat it up, we're going to form also an anhydride. And then what about if we have the carboxylic acid and LiAlH4? Well, LiAlH4 is a strong reducing agent, and we're going to reduce that to a primary alcohol. So now for this one, I recognize that I drew these wrong, so I'm going to redraw these. Okay, but the multiple choice question for this is, into which molecule can amines be converted into? So amines, remember, are the least reactive, the most stable, the lowest energy carboxylic acid derivative, but they can go up in the ladder by one step. So they can form alcohol. I mean, they can form carboxylic acids and they can form esters, right? Because these two carboxylic acids and esters are one step above amines. So for number 10 and number 11, what I originally planned was these questions. So here we have number 10. So the question is this NH, and then if we have H3O plus and heat. So what is the product of that reaction? So if we have an acid and heat with that amide, then we're going to form a carboxylic acid. Right? But if we have the same starting reagent, or starting material, with base and heat, we need to recognize that we're going to form this product, not carboxylic acid, until we use H3O plus or H plus for that matter. And when we do that, that's when we can form carboxylic acid. So that's question number 10. And then question number 11 is going to be using the same starting material, except this time we have, ooh, that's way too close to that. I don't want you guys to think that's together. So let's do it this way. So we have primary alcohol and we have H plus acid. So this is going to form an ester group, and that is the product. So if we keep on going down, we notice that this is where we started. So this has been the material for April 7th and April 9th. This is the SI session that I prepared. If I wasn't clear about something or if I made a mistake, please let me know. Otherwise, if you have any questions about this material, I'm always open to communicate via email. I understand that we're all adjusting to the COVID-19 crisis and how this is affecting us and our families. So I hope everyone is doing well, and that the health of your family and yourself is priority. But otherwise, hope you guys have a great week. And